functions question, and we're asked to find the domain and the range of the function, which means that we need to find the possible x values and then the possible y values of each of those functions. So the easiest thing to do to start with is going to be to sketch what the graph looks like. So you can see on the calculator, we've typed the equation in and we're going to graph it. Now, essentially, what I'm looking for is what are the x values that the graph can take. That's the domain. So we can see here it starts at this point and then it continues on forever in that direction. So if we go to the table of values, we'll be able to find, here we go, 3 looks like it's the first time that the graph exists. However, it could be 2.6, 2.7, 2.8. So we're not 100% sure it's 3, but it looks like it could be 3. If we go to our function, we can use other skills to then confirm if that might be the case. But if you're not sure, then that's certainly going to be a good guess to put in the exam as your answer. So we know that a square root can't be a negative number, and therefore that x minus 3 has to be a positive number. Okay, has to be positive. So if I said x minus 3 is equal to 0, we know that x is equal to 3. So that means that if x is 3, it's 0. If x is bigger than 3, then it's a positive number. But if x gets less than 3, then it doesn't work because it's that negative square root, which is not possible. So that tells us that the domain of the function is therefore going to be that x is bigger than or equal to 3. And you can also write that x can be any value. Okay, so x has to be bigger than 3. This coordinate here must be 3, negative 2. That's starting coordinate. And then asked to find the range, so this is your y values. Now we can see that this is the smallest point on my curve, and then it's going to keep going up. So therefore, we already know that that point is negative 2. So the y values, or the range, have to be bigger than or equal to negative 2. And we can again say that it can be any value. Now notice that we have the f of x and not y, because the function has f of x and not y. So you should always follow that same notation. And then for the last part of the question, you're asked to find f minus 1 of 0. Now we know that when we have a function, for example here, the inverse function has a domain and a range value that swap over. And we talked about how we can always write this down to then use in these kinds of questions. So that means that if I have f minus 1 of 0, I could say, instead of that being the 0 in the f minus 1 or the inverse function, it's when is the original function equal to it. So I can say that this is the same as when is the original function equal to 0. So on my graph here, I'm saying when is the y value 0, which I can just plot 0. Obviously I can also use the zeros, but if it was a different value, you can see here. Find those intersections. And we can see that it's at 7. So f of 7 is equal to 0. In which case, f minus 1 of 0 is equal to 7, because the x and the y, the domain and the range, have then swapped over. So in terms of your marks, there was 1 mark for the first part, 1 mark for the second part, and then 2 marks for the last part, part C. 1 is for realizing that you needed to swap over the domain and range, and then 1 is for the final answer of 7.